Hydrogen can be prepared on an industrial scale using the reversible reaction between methane and steam. So they've given us the reaction and they've shown us that it's endothermic. We can see that there are 2 moles on the left and 4 moles on the right. This reaction is done at a temperature of 800, a low pressure of 300 and a nickel catalyst. Explain in terms of equilibrium yield and cost why these conditions are used. So we're going to do each condition separately. So we'll start with temperature. It looks like it's the level of response. So probably that each condition is one of the levels. So we're going to start with temperature. And we can see that because the forward reaction is endothermic, so we'll write that down, that's interpreting the enthalpy change. According to Le Chatelier's principle, then yield will be favoured by a higher temperature. So a higher temperature shifts equilibrium right in the endo direction to oppose the change and reduce the temperature. So that's why we might use a high temperature. What about the cost? Well, high temperatures are costly. You have to put a lot of energy in. So 800 degrees C is a compromise. Then we're going to look at pressure. So they're using a low pressure. So why might they be using a low pressure? Well, if we look, we've got 2 moles on the left and 4 moles on the right. So a low pressure will shift the equilibrium to the side with the most moles in order to oppose the change and increase the pressure. So we've got more moles of gas on the right hand side. Low pressure shifts equilibrium right to oppose the change and increase the pressure. As more moles exert more pressure. Also, low pressure has a lower cost. So that's good. And then lastly, we've got a catalyst. So remember that a catalyst does not affect yield as it increases the rate of the forward and reverse reaction equally. Now this is a level of response and we may not need that bit, but before a level of response we want to make sure that we're hitting those top levels. So we're saying things that are relevant and that expand on our answer. So I am including that explanation there. Why then would we add a catalyst? Well, adding the catalyst means rate increases. So we needed a high temperature here. So by increasing the rate, a lower temperature can be used for rate purposes. And as a result, this lowers the costs. So we've explained the effective yield and cost of the conditions that I used.